maybe it's a good idea to, yeah, just stop here and look at what is going on first. So we try to see, oh yes, we can read in, yeah. So not surprisingly, we managed to read in the Excel file. So we got that in our DF. So that's definitely there already, right? So it's in our hand already. Now what we do is we open a connection, all right, to the database, which we have already defined here, all right, and then we simply do a DF to SQL. The to SQL part, you need to supply the table and the connection. And you don't have to say how to insert, because it's always a wholesale copy, wholesale movement of the entire data frame to the table. So the only question is, if it exists, what should I do? So if it exists, don't append onto it, causing duplication. What you do is replace. So we specify that if the table out already exists in Pandas Exchange, then replace it. Otherwise, just create that table. Okay, so it will always be there. And obviously, if Pandas Exchange is not there, by the time we do a connect, it will be there. So we just do a SQL out. And for now, let's just close it. All right, so that we can see what's going on. Now, it's a good idea to perhaps, let me just pop this out and shrink it a little bit. Okay, so when we run, we should see the Excel, this prints out again, and then connect and Pandas Exchange should pop out here. Okay, let me just position it for the best display, and I shouldn't cover this up. Okay, so ready. Let's just run it. Go. Okay, there you go. Where is it? Where is it? Here. Okay, so a new database has been created, and it should contain exactly this information, because we did a to SQL out. There's no need to say use insert or use update, because it has to be insert, and it has to be based on the columns order, and it has to have the column headers and so on. So really it's that simple. Just specify the name of the table and that's all. So let's open up using SQLite Studio. So this is our previous account table here, right? We have this new table having the name out. And when we open it, the schema has already been defined by the Pandas to SQL. So we don't have to worry about it. And when we look at the data, that is exactly what we have. Okay, so now that we have successfully taken information from Excel and then sort of dumped it into a table without modification, let's try to modify the sort of read in data from Excel before we well, we have dumped it successfully. Now we modify in place directly this out table. So the plan is that after we moved it out to SQL, to the out table, we create, okay, we create a cursor like this, and then we perform an execute, delete from the table where the P&L. So we're going to remove all these, and then we close it, okay? So what we need to do is we also need to commit, because I'm going to close first and then have a look. So let's run this. Now, the cursor has no commit because, pardon, it's the connection that we need to do to commit. So that's an illustration that if you use cursor to commit, that will be an error. So we read in, okay, we read in the database, and then we find that, oops, it's being locked. Why? It's being locked. We cannot delete from. We cannot delete from because the database here is being locked. We are currently locking it when we open this up like this. So if we try to refresh, we get this. To unlock it, because I think SQLite behind the scenes is locking the database. To unlock it, let's not look at it. Okay, and then we try to run this. Okay, now it returns successfully, but what is happening to our Pandas exchange? Now, if we look at out table, right, all the P&L account rows have been removed, gone, right? But remember, it was performing a sort of replacement. Our Pandas database was there, our out table was there already. It actually dropped the whole thing and then, replace the table content with the newly read in Excel. So if we run it again, we will get back the same table when I exit SQLite Studio. So we will be getting this half table. And what we're going to do is also, other than delete, we'll just sort of tinker it a little bit more. We will perform an insertion of 2 additional rows whose data is nowhere to be found except in our program here, right? The property warehouse and the mortgage UOB. So we use the cursor dot execute many, and this is a standard function to use. Then do the standard layout, insert into out, the table out, the values, 4 question marks for 4 column values to be filled in by the 4 elements in the inner tuples. Okay, so let's run that and see. Obviously, I have to close this. Now it's done. So if I look at out again, okay, and right, so the first 5, they were there originally, and these 2 have been newly inserted. Great, excellent. So what I'm trying to do here is I'm simulating some sort of additional Python programs being run by colleagues or different workstations or different processes, and they all try to connect to SQLite to work on the same table. And we saw just now when SQLite, and kind of luckily because it's up to SQLite Studio to lock or not lock the table while I'm looking at the table itself. So it was locked, and another application, which is our program, tried to modify the table and failed. It waited for a while. Remember, there was a hanging there for a while. It waited for a while. Are you done? Are you done? I think I timed out. So it says database lock. I'm unable to modify it. So that shows that SQLite maintains the integrity, because if you read and write, you also are allowed to write. Another process or program is allowed to write. Then whose version is the later value? So there's going to be a problem. Now, if you cannot feel that it's a problem, imagine if your bank account was being simultaneously overwritten by 2 applications, and then the amount of money left in your bank account is not certain, depending on who writes first, right? One writes 10,000, one writes $1. So if the $1 write is written first and then the 10,000 came in second, then you have 10,000, right? But if it's the other way around, you have $1. So that is the kind of issue that will that a database has to ensure that such problems will never actually become a problem. Okay, so now that we have successfully, through our program, updated the data. Remember, the point is not just to have the data modified in the database, but rather how we perform that. So it is not manually done. It's all done through programs and scripts, okay, or through Excel. So we never try to modify the database directly using SQLite Studio. So once we have that, let's try to read back in. Okay, we have that committed to the database, and we want to read back in, select everything from out, all right, via the connection. The connection is still there, and we print out what we read back. It should be the same as this. Okay, so we're going to close it. And additionally, we're going to dump it to Excel out.xlsx. So it should be here. Currently, there is no out.xlsx. If any, it should be around here, right? OPQ, so it should be here, but it's not there yet. So let's run this. Okay, basically the out table was recreated. Remember, if exists, then replace over here, right? So then we delete it again, and then we insert it again, and then we read back in again, and we write out to the out.xlsx. So let's check our df2. We should see 7 rows, and because Pandas always names them as 0 to 6, so there are 7 rows correctly with the property warehouse mortgage UOB. If we open up our out.xlsx, we should see, not surprisingly, exactly the same content, and without, oops, I didn't say index is false, so we see the index. So we should be saying, or I should have said, comma, index equals to false, then we wouldn't see the index here. Okay, but if, however, the index does store certain meaningful data, like timestamp, dates, something like that, then yes, you actually want the index to be stored as well, and then read back in as well. Yeah, okay, so with this, we actually can feel pretty confident, I hope, that the data can be very comfortably interchanged between all three storage or processing mechanism: Excel, Pandas, and SQL. Okay, so in the final, basically this is the final example. We managed to see how modified database tables from the database can be directly and very conveniently written out via Pandas using the tool Excel. Right, so just extract it out. We can read underscore Excel very easily. We can dump the whole Pandas data frame to Excel, to SQL, just saying to SQL, that's all, right? And the writing out to SQL table is very simple because it's always insert, and you just have to pay attention as to whether, if current row exists, do you append onto it or do you replace the entire table. um, did I say current row? Current table, right? So if current out table exists, do you append onto the out table the entire rows in DF, in the data frame? Or if current table out exists, do you just discard the whole old content and overwrite with overwrite the entire table with the new content? And I would normally just do replace because it's cleaner and I'm very sure that it is correct. But of course, appending is also very useful because we will then be able to, for example, today's transactions, we just DF to SQL transaction table. But we don't want to override it yesterday's and this whole week's transactions, right? So we just say append and we'll just keep on appending daily transactions to the same transaction table. Month end, when we need to tally everything, just extract from the entire table, and that will be the entire month's transactions. Okay, so hopefully you get the feel that moving data around these three platforms really is as simple as that. And you see how many lines, it's not even 100 lines, not even 50 lines, with plenty of spaces and lots of comments and readability embedded within. So definitely try your hands on this and make sure you use them in your projects. All right. So that concludes our discussion of that concludes our discussion of database, pandas, data analytics, and Python. All right. So hope you have enjoyed it and see you in the next video.